Go. I am live. And seemingly there are 0 people in this chat. That breaks my heart a little bit. I'm assuming people are going to be shuffling in, no pun intended, in the next few moments, as I do see that number start to go up a little bit. That's okay. We'll figure this out. So I'm going to stall a little bit just by kind of talking a little bit about what this today is going to entail and what the next few weeks are going to entail, of course, as well. As for today, we are going to continue with probability. I am going to focus a bit more on card playing games today. I put it in the title. I think I said probability of cards or something along those lines. I didn't want to put in like probability of blackjack or poker or something like that because that might be frowned upon or something along those lines. But I am going to be talking about those 2 particular card games. Blackjack and poker, just to give you an idea as to the types of probabilities that players would calculate depending on what they have in their hand and things of that nature. It's going to be fantastic. I am also going to, and it's on my desktop, I have to upload it to the Google Classroom. I am going to be sending you a list of 5-card hands of poker in terms of what beats another hand and stuff like that. It's going to be fantastic. But we're going to be deep diving that kind of thing today. It's going to be nice. It's going to be nice. Now, in regards to this week, you had an assessment due earlier this week. I'm still in the middle of grading those. I'm hoping to get those done hopefully by the end of today. But you did have an assignment due from me today on some probability things. That's due by 2:00 today. So please make sure you're getting that done. Obviously after 11:40, you guys have pretty much the next couple of hours to do whatever you need to do for school. And of course, today is their 10-minute Google Meet marathon, but whatever. We'll deal with that. Now, the next few weeks, I'm looking at a calendar right now. You can't see what I'm looking at, but I'm looking at a calendar. We have 2 full weeks, and then we have a shortened week. It's the week of December 7th and the week of December 14th. We have 2 full weeks, and then a shortened week before Christmas break. Now, I have absolutely no idea what is going to be happening in the next few weeks. I know what the numbers are for COVID and all that stuff. I've been checking it pretty much every day. Yesterday, there was another spike, another record number of cases in the state of New Jersey. And on top of that, if you go to, and this is the unfortunate sense of it all, but if you go the last 30 days in terms of the number of deaths, and that thing has also increased, but just looking at the statistics, that's all I'm doing. So what I would like to do, I'm going to give you a little bit of a lesson on blackjack first, even though, I know how to play blackjack. But I'm going to teach you a little bit of the rules in terms of kind of thinking about cheating at blackjack, but that's besides the point. Not cheating, really, but statistics was first studied as a mathematical subject so that people could cheat at gambling. I do not endorse gambling whatsoever. I don't gamble, but I know all of the rules behind it, which is just so fun. But I digress. So let's start with a little bit of blackjack. Now, what's really nice is that I do have this Elmo camera to show you what the heck is going on here. Flip my screen over. Flip that up. There we go. I probably should adjust the camera, but what I'm doing right now is I'm opening up the Google Classroom on my phone so that I can see what the chat is going on there. If there are any questions, I should lower the volume on that. Come on, you. There we go. Good. So let me adjust the camera just a little bit. With this thing right here, just adjust, just to make it a little bit easier to see. A little bit. Yeah, whatever. Anyway, so in a game of blackjack, if you're not familiar with it, there is a dealer and there are a number of players. And the idea is that the players are not playing against each other. they are playing against the dealer. Let me just see where my size is. Oh, I got to zoom out. There we go. Yeah. They're playing against the dealer. And the game is played to 21. So what I want to do is I just want to give you a little bit of a basic background, and then I want to talk about the probabilities involved with it. So this is a standard deck of cards. My decks of cards are really messed up. I have like 2 different types of cards in here. You can see right here. There's like purple cards and black cards. That's only because I lost some of the purple cards over the course of the years. I don't know. It's really funny. But I do have a full deck. It's got 52 cards. It's got everything that we need. It's fantastic. So it would start off with something like this, where the dealer, me being the dealer, would deal to each of the players, where I would deal a card down. Now, depending on the table that you're playing at, you might be playing with anywhere between, just you and the dealer, or you might be playing with up to 5 to 7 people. So there are my 5 people, and here's the dealer in the middle. Now, that's just the first round kind of going through, and then there's like a round of betting and stuff like that, So then there's a card face up and stuff like that. Boom. Now, there's depending on the casino that you play in, you might have a different set of rules, like depending on what cards are face up and face down and things of that nature. But for our sake, let's think of it like this. Oh, the dealer. There we go. Let's think of it like this. The cards are dealt, and people place their bets. There might be like a minimum buy-in just to get in, and then they place their bets on top of that. Cool. But then after the bets are placed, then the players can reveal their cards. Okay. It's just the way that this thing typically goes. Now, let's just keep track of a couple things here. You want to get up to 21. You want to get as close to 21 as possible without going over. If you get 21 right on the dot, you automatically win. Boom. In fact, these 2 right here are the only ones that possibly could win right off the bat. I don't know what they had. But if they have blackjack, then yay, oh, happy day. I think if you have blackjack, you have to like reveal that immediately or something along those lines. But again, it depends on the casino. If the dealer has blackjack automatically, they do have to reveal that automatically, and everyone loses. But them's the breaks. Like I said, there's a certain minimum amount that you pay to get in. And then after the cards are dealt, there's like a round of betting, depending on the casino that you're at. Cool. But let me just check real quick to see if they got blackjack. Nope, they did not get blackjack, and no, they did not get blackjack. So we're good here. So then everyone kind of reveals their cards, and it's going to go around the arc in that fashion, where people are going to either hit or stand. Yes, there are certain rules for splitting your cards. Like in this case, there's the possibility of splitting the cards. I'm not sure of the rules in terms of betting on that, but let's just pretend they're not splitting their cards. Now, the dealer does not reveal because you're trying to get up to 21, not knowing what the dealer has, because the dealer has certain rules that they have to follow, and we'll see what happens. So then, looking at these cards, you being the first player, just take a quick scan. You're looking at the cards and you see, okay, there's 1, 2, 3, 4, 5 cards being shown that are what I would consider to be low cards. There are 2 that I would consider to be middle-ish cards. And there are 1, 2, 3, 4 that I consider to be high cards. High cards would be like 10, Jack, Queen, King, or Ace. Ace can count as 11 or a 1. Middle-ish cards, again, depending on what strategy you're trying to play, middle-ish cards could be like 7, 8, 9, or 6, 7, 8, 9, or 6, 7, 8, depending on your strategy. And low cards are obviously lower cards. Depending on what's been played, because you're only playing, in this case, with one deck of cards. Now, this is where the probability comes into play. Since you're playing with one deck of cards, you know that there are a finite number of possibilities. Since you're playing with a finite number of cards, you know what cards have been played for the most part. So you know what cards could potentially show up next. Again, finite number of cards. So far, there's been 2, 4, 6, 8, 10, 12. There's been 12 cards that have been played, which means there's only 40 left in the deck. This is a conditional probability. This is a conditional probability. And the deeper you go into the round of blackjack, the deeper you go into the round of blackjack, the more you might have an idea as to what cards could potentially show up next. Some casinos have tried to fight against this by having multiple decks. So instead of having one deck, you'd have two decks, and then after like a round of betting or something, maybe they just like change decks. I don't know. It just depends. They have like a little machine that kind of shuffles all the cards together. It's like a blackjack shuffler or something like that, but whatever. So this person has 8. And again, there's a lot more lower cards being played, so that they hit, and they got 18. And I wouldn't want to risk that. I'd stay at 18, But again, kind of keeping track of the cards that have been being played. That's another high card that's been played. This person has 11. They're in a good spot because with an 11, you could easily jump to 21. Boom. They didn't get it. They got 18. Again, probably something that they want to stay on, especially considering the fact that the dealer has a 3. If the dealer has a 3, then most likely there's going to be a bit of hits going on here. I believe that, again, depending on the rules, if the dealer has 15 or 16, I think the rule is that they do have to hit. But then anything above that, they do have to stay. Like they're not allowed to play the strategy. 18, I'd probably stay. 20, I'd probably stay. 12, probably got a hit, assuming that this guy has like 13 or 14 at best. Boom, that person's busted. They lose. Sucks to be them. Goodbye money. And that was up to the dealer. So the dealer has to play. The dealer right now has 8. Boom, the dealer has 18. Ugh. This is where they would have to push. So anyone with 18 automatically loses. This person, the one with the 2 queens, automatically wins. That's the general idea of blackjack. You have to beat the dealer. The dealer busts, and so be it. But you got to beat the dealer. If you tie the dealer, sorry, you lost your money. Goodbye, blackjack. Blackjack is a quick and easy game, and it's very easy to get yourself lost in it, especially if you're actually betting real money. I've seen it happen. I've seen it happen to various people. Again, I don't gamble. I don't like gambling. I don't believe in gambling. I've seen too much of it when I was a kid. Too much real gambling, let's just put it that way. And I can see the addictive purposes of gambling. That's why there's like there's like gambling anonymous groups and junk like that. Anyway, so there's a shuffle being done with a deck of cards. It's a brand new shuffle. And now we're going to keep track of certain things. Now I'm going to deal the cards, and I'm going to write some stuff on the board in regards to the probabilities that are happening here. Because again, you got 52 cards. 52 cards. Let's see what happens. So the dealer would start here. Again, you're assuming you're playing with 5 people. You could be playing with up to 7 if you wanted, not if you wanted to, but like if the table at the casino had that many people. And then here come the cards. Now, of course, everyone has paid a minimum amount to get in. Everyone's paid a minimum amount to get in. Keep that in mind. Like I said, obviously, now, here's the thing. If this person has blackjack, if this person with the queen is blackjack, they automatically have to show it. They have to show it. Because if you have blackjack, then when you get to the round of betting, you'd be like, yeah, I'm all in. No. If you have blackjack, the rule, you got to declare it. They don't have blackjack. So there's a round of betting, and then the cards are revealed. But I'm coming up to the board right now because I want to write some stuff. So I would usually, in my mind, keep track of the high, middle, and low cards. So these would be high cards, these would be middle cards, and these would be low cards. Now, for the sake of our purposes of gambling, let's assume that 10, jack, queen, king, and ace are considered to be high cards. Yes, ace can be a 1 or 11, but we're keeping track of it as a higher card just for the sake of argument. 9, 8, 7. Let's consider 9, 8, 7 to be middle-ish cards. And then anything below that is considered a low card. So again, we're just kind of keeping track of things. Now, when you're at a casino, you're not allowed to like write or keep track of things like that. You're actually not allowed to. It is very discouraged at a casino that you write anything down or that you do this kind of stuff. It's not illegal. It's not illegal, but it's discouraged, and it's the casino's rules. So I would keep track of something like this in my head. I said 7, 8, 9 would be middle, and then 6 to below. Cool. So I have those kind of counts right there. But again, it's hard to keep track of something like that in your mind. So what people what players tend to do is they do a very basic system of a count in their head, where they consider each low card to be let's say a +1. They consider each middle card to be a 0. And they consider each high card to be a -1. I'm going to write that over here. I'll write this over here in black. So the low cards would be considered +1. The middle cards would be considered 0. And the high cards would be considered -1. And the idea is that depending on where your count is, you can make a determination as to what are the chances that a better card, a higher card, a card that could potentially get me something is going to come out next, or a lower card if I needed it. So right now, the count is pretty low right now. The count is pretty low. It's just +1, or not +1. I'm sorry. This is +3. This is nothing, and this is -1. So the count's actually at 2 right now. If you play at a casino where instead of using one deck, they use like 5 decks, this system really comes in handy because they have to go through all 5 decks before they change out the cards or something like that. So it's actually to your benefit to do that. Oh, gambling. So round of betting, the whole thing, and then we kind of keep track. All right, let's see what happens now. Now there's a new cards that are going to be revealed. These cards are going to be revealed right now. So there's a 4 that's revealed. There is a 9 that's revealed. There is a queen that's revealed. There's an ace that's revealed. And there's a king that's revealed. So let me go keep track of that on the board real quick. So that 4 was revealed. That was a low card. The 9 was revealed. It was mid. The queen was revealed. The ace was revealed. And the king was revealed. Now, again, keeping track of the count in your mind, middle cards don't do anything. There are 4 low. There are 4 high. You would consider the count to be 0. Again, not really an advantage one way or the other, but this is what people do if they really want to cheat at gambling, or basic kind of systems. There are way more advanced systems going on, way more advanced systems than this, but let's just see what happens. So they have 10 at the moment. They definitely got a hit. You have to assume that the dealer has something like 17 or 16, something in the teens, basically. That's what you have to assume. So I got 10. I got a hit. Oh, I got 20. Yay. I'm going to stay. 9 and a 3. You got 12. Again, being that there's 12. Now, keeping track of the count, there's one more king that's gone. There's one more high card that's gone. You got to think about how many high cards there are that are left. When you're dealing with a game of poker, you got to think about how many high cards are left. Boom, there's the king right there. Well, there are, what was I, 10, jack, queen, king, ace. There are 20 high cards to choose from, and 5 of them are already gone. So let me just write this here for myself. There are 20 to choose from. For middle cards, there's only 12 to choose from, and 2, 3, 4, 5, 6. There are 20 to choose from the low cards. That's typically how they break that thing up. Again, with this many cards gone, you kind of know what your chances are of getting a different type of card later on, but you really have to kind of keep track of it on the fly because you're not allowed to write any of this crap down. 9 and a 3 is a 12. They hit. Boom. They got 18. Good for them. Probably staying in 18. Cool. They get 18. They're probably going to stay. Now here, because ace counts as a 1 or an 11, they either have 3 or they have 13. Either way, they're going to hit on that. 3 or 13, they're going to hit on that. Boom. Good thing that ace was worth 1. Now they have 13. But again, with 13, I got to keep track of this. Hold on. So that 6 was drawn out. That 6 was a low card. Boom. They got the jack, which was a high card. Boom. Now the count right now is -1. The count right now is -1. Being that it is -1, you're going to assume there's a higher chance of a lower card popping up. There's a higher chance of a lower card popping up. This is conditional probability. They hit, boom, they got a 2. Now they're in a world of hurt Oh my gosh. Now you got a 2. Now the count's back down to 0, which means there's equal chance of high and low. Of course, there's a bunch in the middle that you could get still. Oh my gosh. What would you do here? 15? Yeah, 15. That is such a terrible position to be in when you have 15 and the dealer's showing 7. What do? Now, obviously, we're not playing for real money right now, but if you were actually playing for real money, this would be the fret that you would have. Some people are like, let's gamble. But again, this is real money for some people. Now, the statistics basically say, okay, assume that this guy has like a 16 or a 17. Assume that. You have to assume that. And if you're going to assume that, if you stop right now, you're going to lose. If the dealer has a 16 or a 17, the dealer may not be allowed to hit. So the dealer would have to stay. So, got to hit. 15. Boom. Bust. Sucks to be them. Well, it sucks to be you if you did that. Chapow. So, 5, 6, 7. There are 13 high cards left. There are, I can't even think right now, 14 low cards left. This guy's going to stay. Then we got the 7 to choose from. Well, you better hope that that this card was low. 15. They got a hit. They got a hit. They got a hit on that one. 15. Now everyone's kind of happy now, because now let's say there's a good chance of this person busting. The dealer, I should say. The dealer's got a hit, but the dealer's probably only going to get one chance. Chapow, bust. Everyone wins. That's blackjack. I mean, it's not actually blackjack. Blackjack's getting the ace and the whatever. Anyway, shut up. There's a lot more math involved on the fly when it comes to games like blackjack. There's a lot more conditional probability that people have to keep track of while you're playing. And at the same time, if you're actually trying to keep track of it in the casino is going to get extra mad at you. And they actually do have the right to kick you out. Casinos are really weird. I don't know if you've ever walked through a casino. I'm going to assume that none of you have actually gambled at a casino. If you had, shame on you. I don't know. I don't care. But if you've ever walked through a casino, there are no clocks on the wall. There are no clocks on the wall. And when you walk into a casino, you can check your cell phone. You lose signal, meaning you can't receive any phone calls. Something along those lines. Everything about the casino is designed to keep you inside and gambling. Everything. It's really, really messed up. It's what they do here. But, Zim's the breaks. It's a really great movie. I'm going to suggest this. There you go. You walk through once. Yeah. I'm gonna suggest a movie for you guys, just because it's really interesting. Matt Damon and Ed Norton in this movie called Rounders. It's pretty fun to watch. It's called Rounders. It's a movie from 1998. Matt Damon, Ed Norton. It's pretty cool to watch. It's called Rounders. Again, I'm repeating it just so you can kind of get that in your head. There's also another movie that I would suggest. There's a little bit more math involved with it, with the gambling and the probability and stuff like that. But it's called 21. I mentioned it last class. It's called 21. Kevin Spacey is in it. Although I know Kevin Spacey is not really on everyone's happy list nowadays, but it's Kevin Spacey, even though he's not the star of the film. He's actually the what are they called? The antagonist? Yeah, the antagonist. Whatever. I don't care. Whatever. But it's pretty fun to watch. So anyway, Rounders and 21, 2 pretty good movies with gambling and card playing and things of that nature, and people making bad decisions. Anyway. Oh, goodness gracious. So, I am going to talk about poker before we leave here today. I'm going to talk about poker, and I am going to email you 5-card hands of poker, just so we can talk about that a little bit more. But there is a little bit of information that I do need to get to you in regards to probability, some notation, some definitions that we have to talk about. The really interesting thing, I just want to point this out. I just want to point this out to all of you. If this were a normal year, if you were here with me today, and I've done this in previous years, if you were here with me today, and if it was a normal year where we didn't have all this COVID crap, I would have literally set us up with like a poker setup, and I would have literally been the dealer with you guys playing with chips. And we would have done that for like the first like 20 minutes or so of class. I am so sad that I am not able to do a lot of the things that I have done in the past when it comes to this class, because like we do with statistics and surveys and things of that nature, and I would have had you guys go out and collect data from other kids in the school. Like, we can't do that this year. Anyway, I just wanted to point that out. But in the meantime, I'm gonna need those notebooks out and open. Okay, bring that there. Like I said, we're going to talk about poker in a little bit, but I got to get you some definitions and things of that nature. So this is just going to be, what is today? Today's the 4th. And this is just probability continued. Nothing fancy. Just probability continued. Okay. Some notation that you need to know. Let's talk about a complement. At this point, I would tell you to compliment me on my tie, because my tie is awesome today. But no, it is not that type of compliment. Sorry. Let's just put it this way. The probability of A is the probability of event A. The probability of A with this apostrophe. You can't see it. There's a little glare there. Let me zoom in. There we go. A little bit better. There's an A with a little apostrophe here. That apostrophe is not read as the word apostrophe. That apostrophe is read as the word prime. So you would read that the probability of A prime. The probability of A and the probability of A prime are complements. Now, what that means is this. If the probability of A is 75%, then the probability of A prime would be 25%. They complement each other. The general idea is that if you were to add the two of them together, you would get 100%. If the probability of A is 99%, then the probability of A prime is 1%. They're complements of each other. I think back in geometry, you did something similar with what they called complementary angles. Complementary angles added up to 90 degrees. In this case, these complementary probabilities add up to 100%. So just a general idea there. There is one thing where they kind of talk about, they're like, well, if you want the probability of A prime, it's simply 1 minus the probability of A. Well, yeah. If you wanted the probability of A prime, the complement, you'd be like, okay, well, if the probability of A was like 15%, 1 minus 15% would be 85%. Yay, we did it. So, geometry. Oh, goodness gracious. Now, let me give you like an example for this, okay? Let me give you an example for this. Example. If you were doing a multiple choice assessment, let's just say you were doing a multiple choice assessment. So, multiple choice assessment with 4 problems. Cool. multiple choice assessment with 4 problems. Now, if you had 4 problems, there are a certain number of answers that you could get correct, and there's a certain number of answers that you could get wrong. You could get all of them right. You could get 3 of them right. You can get 2 of them right. You can get 1 of them right, or you can get none of them right. Something along those lines. So you could say something along the lines of the probability of 0 wrong, that's 0 wrong, plus the probability of 1 wrong, plus the probability of 2 wrong, plus the probability of 3 wrong. I'm dealing with wrong answers right now for some reason. I don't know. Plus the probability of 4 wrong. I'm just looking at it from the wrong point of view. No pun intended. Ha 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 ha. But that should all add up to 1. That should all add up to 100%. If you're doing a multiple choice assessment with only 4 problems, that's what the glare is right there. It says 4 problems. If you're only doing it with 4 problems, then these are all of the possible outcomes that there could be. You could get none wrong, meaning, yay, perfect score. You can get 1 wrong, 2 wrong, 3 wrong, or 4 wrong. Those are the only possible outcomes. They should, all of these probabilities, add up to 100%. This is called a probability distribution, because the distribution, the probability is spread out amongst all of them. There you go. Now, what I bring this up for is because of that idea of the complement really helps when asking the following question. Okay, if I wanted the probability of at least 1 wrong, if I want the probability of at least 1 wrong, at least meaning 1 or more wrong, then I don't have to actually calculate all of these probabilities. See, because if I'm doing at least 1 wrong, if I wanted to do it the hard way would be calculating 1 wrong, 2 wrong, 3 wrong, 4 wrong, and then adding them all up. Because of the OR principle. The OR principle is the fact that you would add all of the probabilities together. There's nothing that they have in common with each other. There's no overlap between them. You can't have both 1 wrong and 2 wrong. That's not possible. But if you wanted the probability of at least 1 wrong, you could say, okay, probability of 1 plus the probability of 2 plus the probability of 3 plus the I don't want to do that. Instead, we can utilize a complement and do this. 1 minus the probability of 0 wrong. If we just simply knew what the probability of no wrong or none wrong was, you could just do 1 minus, boom, you have your answer. Try and do it in the simplest way possible. Trying to do it in the simplest way possible. Amazing. One more thing that I want to talk about before we talk about poker. Let's talk about rolling dice. I don't know if you've ever played craps. Craps is an interesting game as well. Craps is an ovalish table in which you have one person sitting at the head of the table, or not sitting, they're standing really, but they're standing at the head of the table and they have 2 dice in their hand. And everyone places their bets as to what they think the outcome of the dice are going to be. Even number, odd number, I'm going to this one, I'm going to do this, whatever, you know. And then the person rolls the dice. If the person rolls a 7 or an 11 as a total, everybody wins. Everybody, no matter what you bet on. That's why they know that I'm on a roll, roll 7 or 11. Cool. In fact, rolling a 7, you have the best chance, actually, of rolling a 7 as an individual sum. There's actually only a 6 out of 36 chance that you would roll a 7. A 6 out of 36 chance. It's 1 out of 6. Now, 1 out of 6 means you do have a 5 out of 6 chance that you won't roll a 7. Keep that in mind. But if you roll a 7 or 11, everybody wins. If you roll snake eyes, which is a double 1, or 12, which is a double 6, if you roll that, then everybody loses. And then if you don't roll a 2, a 7, an 11, or a 12, then people get to bet on the resulting numbers as to whether or not they win or not or something. It's really weird, really weird. Craps. It's called craps. Anyway. Rolling 2 dice is a very common probability type problem, which I am going to talk a bit more about dice next time, but I wanted to make sure that you had the following frequency chart for rolling 2 dice so that I don't have to reteach the thing again. Let's talk about rolling 2 dice. Rolling 2 dice, they're talking about the sum of rolling 2 dice. The sum versus the frequency of that event happening. The sum versus the frequency of that event happening. Now, there actually are 36 possible outcomes when rolling 2 dice. 36. There are 36 possible outcomes when rolling 2 dice. The lowest outcome you can have is a sum of 2. That can only occur in one way. Let me get this dice here. Here we go. Where are my dice at? There we are. Boom. Getting a sum of 2 can only happen in one way, getting a 1 and a 1. But getting a sum of 3 can actually occur in 2 ways. It can occur in 2 ways. I'm going to show you here. Look at the red die. Look at the green die. Now look at the red die and look at the green die. There are 2 distinct outcomes. They are 2 distinct outcomes. The first die and the second die. There's 2 ways of getting it. You could roll a 1 and a 2 or a 2 and a 1. It has been proven that those are 2 distinct outcomes. Now, what about a 4? To get a 4, you could roll a 2 and a 2. You could roll a 1 and a 3, or a 3 and a 1, I should say. Or you could roll a 1 and a 3. There are 3 ways of doing that. Rolling a 2 and a 2, one might argue, but then switch the die. Yeah, but if you switch the die, it's still the same outcome. It's the exact same outcome. So you only count it once. So rolling a 4, you would get a 2 and a 2, a 1 and a 3, or 3 and a 1. Do you see the pattern here? There is a pattern here. There's a very distinct pattern here. Now, I'm actually going to run out of room. I may have to continue the table over here. Let's just see what happens. 5, 6, 7, 8. Yeah, I'm going to continue it over here. 9, 10, 11, 12. I ran out of room. You can continue the chart on your own paper. Sum versus frequency. How many ways can you roll a 12? There's only one way of doing it. 6 and a 6. How many ways can you roll an 11? Because you can win if you roll a 7 or an 11. There's 2 ways of doing it. You can get a 5 and a 6, or a 6 and a 5. You can hopefully at this point see the pattern. Yes, there's 3 ways of rolling a 10. There's 4 ways of rolling a 9. There's 5 ways of rolling an 8. Now, I want to think about that for a second. 5 ways of rolling an 8. Let me just list them out here. 5 ways of rolling an 8. 4 and a 4. Hold on. 4 and a 4. 5 and a 3. 3 and a 5. 6 and a 2. 2 and a 6. There's 5 ways of rolling an 8. And ultimately, as I said, there are 6 ways of rolling a 7. 6 ways of rolling a 7. I have no idea whether or not you guys are the crowd of people that have ever played the game Settlers of Catan. But if you have played Settlers of Catan, then you understand the frequencies of rolling 2 dice and the events that happen as a result of that. If you haven't played Settlers of Catan, shame on you. The probability of rolling a 7. Now, if you added up all these frequencies, it adds up to 36. Rolling a 7, there's a 6 in 36 chance of that happening, which is approximately equal to 0.167. Yes, you probably have seen this chart before. You probably have. I'm not even joking. Probably in like middle school at one point or another. But knowing this chart is going to come in handy when answering the questions of rolling 2 dice. Now, like I said, I am going to be coming back to this chart in a little bit. I wanted to spend the remainder of my time talking a little bit more about poker, but I wanted to make sure that you at least had this chart written down. It's incredibly helpful to know this chart. In fact, if you recognize the pattern, you can memorize this and no problem. You don't have to spend any time really memorizing this. Just recognize the fact, okay, the lowest sum I can get is 2. The highest sum I can get is 12. I know that. And it starts out 1, 2, 3. And then from the bottom, it starts out 1, 2, 3. And then they meet at the 7. They meet at the 7 right here where Ms. Markey is pointing. And that's a 6. Yeah. It's a symmetric frequency. It's symmetric. If you were to actually, see, I don't think I have it on my calculator. Hold on. Oh, I do. Probability simulator. Here we go. Check this out. Zoom in, zoom in, zoom in, zoom in. I have a probability simulator on my calculator, and I can roll dice, right? And let me change something here. Let's change it to 2 dice. Okay. Data. There's no data to export. Cool. I'm rolling 2 dice. Hold on. I want to roll it how many times? Trial set. Ooh, can I go advanced? No, I don't want to weight the die. I'm not going to weight the die. Okay. Roll them. Rolling the 2 die. It looks like I got a 7. But the reason why I bring that up is because now I can hit this button right here and I can roll it 50 times. Watch. It's going to do it 50 times. Now, what do you notice about the shape that is emerging? I'm going to do it another 50 times in a moment. But what do you notice about the shape that is emerging? It's basically collecting the data of rolling it that many times. And all the way to the left is the sum of 2, and all the way to the right is the sum of 12. 7 is the most likely outcome. Thus, you can see that peak right in the middle, like a big middle finger. But as I do this more and more, the shape of the distribution is normal. It is a normal distribution. Data, depending on how it's structured, sometimes naturally occurs as a normal distribution. Now, if I were to do this hundreds and hundreds and hundreds of times, the law of large numbers, if I were to do this thousands of times, eventually the experimental probability right here, what I'm pointing at, this is all experimental probability, would approach theoretical probability. That's what it would do. But I digress. I love this thing. I'm really glad I had it on the calculator. Not all of these calculators have a probability simulator, but it's really nice that this one did. Anyway, to poker. So, on my Google Classroom, I believe I can attach it. I have it on my desktop. Poker hands. I believe this will work. Come on. Now you're not going to load? I have this thing of poker hands on my desktop. Let me go to the desktop real quick. Poker hands. Where are you? Poker hands. See? I got a poker hands right there. Poker hold hands. And that's the GIF. So let me go back here. Let's cancel and try it again. Poker hands. It worked. It worked. All right. Hopefully that'll work. Let me see if it does work. Let me post it. Poker hands. Post. Excellent. So check that out right there. You can see that a little bit better. But these are the possible 5-card hands in a game of poker. Obviously, it's a bit difficult to see on my screen right now, which is why I just threw it into the stream on the Google Classroom so that you could see it right up front. But these are the possible poker hands. Royal flush, straight flush, 4 of a kind, full house, flush, straight, 3 of a kind, 2, pair, and high card. Now, what's really interesting about this, obviously, these are not the only kinds of royal flushes that you can get. There's 4 different kinds of royal flushes that you can get. 4 different kinds. They could be all hearts, all diamonds, all spades, all clubs. You know, in terms of a flush, where's the flush? There's a flush. It doesn't, you're looking at getting all clubs there. Now, obviously, this isn't taking into account. Like a straight flush. A straight flush is a different kind of flush. It's a bit more rare. But the order in which all of these hands are written in is the order in which hands win. Different hands win a game of poker. So, for example, if you had a pair and I had 2 pair, I would win because 2 pair beats a pair. A full house beats a flush. 4 of a kind beats a full house. 3 of a kind beats 2 pair. Stuff like that. Now, it's not that they just randomly determined that one hand would beat another hand. They didn't randomly determine that. What they figured out was the mathematics behind it. The probability of the hand showing up, the probability of getting a flush is lower than the probability of getting a straight. That is why a flush would win. The lower the probability, the better the hand of poker that you have. That is how they determine what wins and what doesn't win. Now, in a game of poker, typically you are dealt 5 cards, and then there's a round of betting, and then you turn in the cards that you don't want in order to get new cards to replace them. But that is a very basic way of playing poker. The most popular way of playing poker is a game called Texas Hold'em. It is one of the most famous 5-card hands of poker that you could potentially have. The way that it works, I'm going to give you a very basic lesson right now. Boom. Very basic lesson in Texas Hold'em because I got about 6 minutes. There is a dealer and there are players. You can have up to 9 players, actually, believe it or not. You can have up to 9 players playing. But for the sake of our argument, let's just say there's like 2 people playing, okay? 2 people playing. Oh, I'll zoom out. I got to zoom out on that. There we go. So there's 2 people playing, and I'm the dealer. So I deal them their cards. Cool. Now, they don't know what each other has. The dealer, you're not trying to beat the dealer now. You're trying to beat everyone else at the table. Doesn't matter what the dealer's doing. It matters on what everyone else is doing. You have to have the best hand, or you have to bluff your way into people thinking you have the best hand. So there's a round of betting. Cool. There's like a buy-in to get your, to play the hand. Let's say you get the cards for free, unless you're the big blind or the little blind, but that's a different argument altogether. So now, again, you don't reveal your hand. You don't reveal them. But again, for the sake of argument, let's reveal them just so we can see what's going on here. This person has a 10 and a 5. This person has a 10 and a 7. Okay. They both have crap hands. Unsuited. Cool. After a round of betting, these two people decide to play. They're like, I'm going to play. No one knows what I have. Maybe they'll think I have good cards. Cool. So then there's like a burn where they like burn like 3 cards, and then they do the flop. Now the flop, these are community cards. These cards can be used by anybody. And what you're trying to do is you are trying to make the best 5-card hand you possibly can. Now there's 2 more cards that are going to be played, called the Turn of the River. But let's just see what happens. Now, this person right here with the 7, they have a good shot. They have a 6, 7, 8, and a 10. They have a possible straight. Possible. It's not guaranteed, but they have a possible straight. With this person with the 5, they kind of also have this possible straight, but it's less likely. They have a 5, 6, 8, 10, I don't know. The 3 is in there too. So let's just say they bet again, because they have to bet again, and they both stay in it. They're like, nope, I'm going to make them pretend that I have the better hand. Nice. So they burn a card. Boom. There's the turn. Oh, pair of 6s. Now, if I'm this guy right here, and it's my turn to bet, maybe I'll make him think that I also have a 6 in my hand. Maybe I'll make him think that I started out with a pair and now I got 3 of a kind. Because nobody knows what I have except me. This person still doesn't have their straight. They don't really know what to do. So a round of betting goes around, and again, boom, boom, and there's a king. So here's the thing. King doesn't help anybody. There's another round of betting. People can go all in. Like I'm going to bet, $1,000. And you're like, ooh, I don't know if I want to bet $1,000. If you fold, I win. If I fold, you win. It depends. If you bet and raise me, I can re-raise. There's a whole bunch of rules behind it. But this particular hand, oh my God, everybody sucks. They both have a high card of 10. They could also use the king. This is a draw, actually. One might say, oh, he has the 7. Yeah, but again, it's the best 5-card hand. It's the best 5-card hand since nobody has a pair. And, well, they both have a pair of 6s, and they both have the king. They both have a high card of king. Everyone splits. What a dumb hand of poker. So they would split the pot at that point. Cards are reshuffled. We do it again. All right, we're going to do it again. Boom, 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 boom. Again, you can play with up to 9 people. There's a round of betting, depending on what the cards they have. No one knows what you have. Ace, that's a good start because you're getting a 5-card hand of poker. Oh, 3 and a 4. Suited. They're suited, which means you have a possible flush and a possible straight, but they have the ace, but you don't know that. Okay. They burn 3 cards. Oh, whoa. Oh, my goodness. Pair of aces. Now this person's feeling pretty good right now. But you know what? So is this person. This person's feeling pretty good right now because their straight draw is still alive. They can still possibly get a straight. But he doesn't know that. He just knows he's got a pair of aces. So they do a round of betting. I'm going to make you believe that I did really good. There's a burn. Oh, there's a 9. 9 doesn't help anybody. Maybe they both check. Cool. Burn the card. Here comes the 7. Oh, now this is interesting. There's no flush because you need 5 cards to do the flush. Boom, 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 boom. You only got 4. But again, he might be like, well, maybe I can make him believe that I have the flush or something along those lines. It depends. It's a psychological game. It's a psychological game. At this exact moment, this person has won the hand, but they either have to, maybe they know they won the hand and they want to bet more money in order to get more money out of him, Or maybe they don't know that they won the hand. Maybe they think, oh crap, maybe the other guy has the flush, and the other guy begins betting big, and then this guy can fold. And if he folds, boom, this guy wins. You either have to have the best hand, or you have to convince the other people that you have the best hand, forcing them to fold. We're going to play a little bit more of this as time goes on. Going to talk about the probability involved with it. But for now, that's my time. Again, I wish you were here in person so that we could actually play poker. I have chips. But such is life. C'est la vie. Anyway, please make sure that you have gotten that assessment done, or the worksheet done in Google Classroom that is due at 2 o'clock today. I'm just checking it right now. Yep, 3 people have turned it in. But make sure that you are getting that done. And if you have any questions, make sure you are emailing me. All right, guys. Have fun. Bye, 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 bye. Have a good weekend. Bye, 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 bye. Cool.